This is for Algebra 2, and this is going to be your retest for the Rationals unit. What you're going to need to do is anything you missed on the exam, you need to work that problem off of this retest. I will go through. So for example, if you got number 1 right, you don't have to answer number 1 on this retest. You only have to do the ones that you missed. You will get half credit back for each one that you do. Okay, number 1 and 2, 3 and 4 wants you to simplify. So you've got to factor and then see what cancels. So on the top of this, we're finding the factors of 27, 1 and 9, 1 and 27, 3 and 9. Signs are different because of the negative. The biggest one is negative. They have to equal 6, so I'm going to do 3 and negative 9. So my top becomes m plus 3 and m minus 9. On the bottom, I am still finding the factors of 27, 1 and 9. Once again, I keep trying to do that. 1 and 27, 3 and 9. Signs are the same this time, and they're all negative. They have to equal negative 12, so it's negative 3 and negative 9. So the bottom becomes m minus 3 and m minus 9. So now you look and see what will cancel. My m minus 9 cancels. The m plus 3 and m minus 3 will not cancel because one is positive and one is negative. So my answer is m plus 3 over m minus 3. Looking at number 2, I'm going to take the top and see what I can pull out of it. They both divide by 14 and they both have an a squared. When I do that, I'm left with a minus 2. Looking at the bottom, they have nothing in common, so I'm going to say what is 7 times 36? 252. So I'm going to come over here and I'm going to find the factors of 252. 1 and 252, 2 and 126, 3 and 84, 4 and 63, 6 and 42, 7 and 36, 9 and 28. Signs are different. The large ones are negative, and they have to equal 36. It's going to be 6 and negative 42, but you can't write it yet. You got to pull over the 7a squared plus 6a minus 42a minus 36. Pull out an a, and you have 7a plus 6 minus, pull out a 6, and you have 7a plus 6. So the bottom of this is going to be 7a plus 6 and a minus 6. This was a divide, so I'm going to change that multiplication. I'm going to flip the second one. So 6a minus 12 actually goes to the bottom. When I do that, I'm going to pull out a 6, and it leaves me a minus 2. 21a plus 18 goes to the top. I'm going to pull out a 3. It leaves me 7a plus 6. So my a minus 2 is going to cancel. My 7a plus 6 is going to cancel. My 3 will go into 6 2 times, and my 2 will go into 14 7 times. So on the top I have a 7, and I have an a squared, and on my bottom I have an a minus 6, and that's the solution. Looking at number 3, we are subtracting, so we need to find a common denominator. First of all, I noticed that 3p minus 12 both divides by 3, and it leaves me p minus 4. So I draw my fraction, my common denominator. The first denominator just automatically gets written down. And then I look at the next one. Do I have a 3 written down? Yes. Do I have a p minus 4 written down? No. I have a p, but I don't have a p minus 4, and it's all or nothing. So p minus 4 goes there. So then I compare. This is a 3p. That's good, but it needs the p minus 4, so write it up high. The next one, the 3 is good. It's missing a p, and the p minus 4 is good. So that gives me p minus 4 times 5p, and I'm going to distribute. 5p times p is 5p squared, minus 5p times 4 is 20p. This is a subtraction, so be careful. We're distributing like a negative p is what I would say. So negative p times p is minus p squared, and negative p times 3 is minus 3p. So combine like terms on the top. 5 minus 1 is 4p squared minus 23p all over 3p times p minus 4. You need to realize that you can pull a p out at the top, so it becomes p times 4p minus 23 all over 3p times p minus 4. Your p is going to cancel, and your final answer is 4p minus 23 over p minus 4. Number 4, we are multiplying, so we're just going to see what we can cancel. 1 and n plus 10 are good. All of this will divide by a 3, and that's going to leave me n squared plus 3n plus 2. So I'm going to come find the factors of 2. 1 and 2 sounds the same. They're all positive. They ought to equal 3. So the top here is actually 3 and n plus 1 and n plus 2. And I don't need that, and I don't need that. The bottom here, I can pull a 3 out, and it leaves me n plus 1. So I don't need that. Okay, so my 3 cancels, and my n plus 1 cancels. And it looks like that's it. So on the top, I have a 1 that doesn't really matter, and I have an n plus 2. And on the bottom, I have an n plus 10. That's all it cancels because those have a plus in them, and it makes it all or nothing. All right, going to the next page and looking at number 5. We are solving for this, which means we've got to find our restrictions, and we've got to find our least common denominator and all that good stuff. So first of all, you want to factor k squared minus k minus 12, minus 2, find the factors of 2, 1 and 2. Signs are different, largest is negative. So this is actually going to be k plus 1 and k minus 2. So restrictions, k plus 1 gives me x cannot equal negative 1. Use the opposite sign. K plus 1 I've already done. K minus 2 says that x cannot equal positive 2. K minus 2 I've already done. So just to help myself out, I like to list my common denominator, and it is x plus 1 and x minus 2, or k, whatever letter you want to use. So when I compare my common denominator with the bottom of this fraction, it's missing k minus 2. This one is all good. This one is missing k plus 1. So I've got k minus 2 times k, because it was already there. Bring down my equals. 3 times 1 is 3, minus k, it was already there, times k plus 1. It really doesn't matter the order for each one of these as long as it's all there. Once you have it written like that, you're ready to go to y1 and y2 to get your answers. So looking at y1, let's get all of this cleared out. And y1 is open, x minus 2, close x. y2 is 3 minus x, open, x plus 1. So then you're going to say second calc, 5, let it draw. Notice they cross twice. I'm going to have 2 answers here, enter, enter, enter. My first answer, x equals negative 1. But then you need to go back and do it again. Since they're crossing twice, there are 2 solutions. Second calc, 5. And I'm going to go over here to the other place that they cross each other. Enter, enter, enter. And x equal 1.5. And you have to give both of those answers. Can't just give one. Looking at number 6, there is no variable in the bottom. Therefore, there will be no restrictions. You have to have a letter in the bottom to cause a restriction. Common denominator, though, 2, 4, and 8 will all go into 8. So 8 divided by 2 is 4, 8 divided by 4 is 2, and 8 divided by 8 is 1. So you have 4 times 2n minus 3 equals 2 times 3 plus, you don't need the 1, so n minus 4. You're going to go to y1, you're going to go to y2. So at y1, you're going to say 4, open, 2x minus 3, close. At y2, you're going to say 2 times 3 plus x minus 4. Second calc, 5, let it draw. They only cross once, that means I only have one answer. Enter, enter, enter. X equal 2. And that is my solution. Number 7, you need to recognize you have a difference of squares. This is x minus 3 and x plus 3. So your restrictions, x cannot be 3 and it cannot be negative 3. Got to use the opposite signs of what you're seeing there. Common denominator is x minus 3 and x plus 3. This one is good. Oh, but be careful. Because what else is a common denominator? And that's not good. You have x minus 3, you have x plus 3. 3 minus x is part of your common denominator. X minus 3, x plus 3, and 3 minus x. Because it's written backwards, so you can't just ignore that. So this one is missing x minus 3 and x plus 3. And this one is missing x minus 3 and 3 minus x. So you're going to have 13 times 3 minus x plus 3 times x minus 3 times x plus 3 equals 2 times x minus 3 times 3 minus x. And once again, you're going to go to y equal. And at y1, you're going to say 13, open parentheses, 3 minus x, close parentheses, plus 3, open parentheses, x minus 3, close, open, x plus 3, close. Then you're going to go to y2. You're going to say 2, open, x minus 3, close, open, 3 minus x, close. It ought to have it all. Second calc 5, let it draw. Looks like they're going to cross twice. That means 2 answers. First one is x equal 2. Do this again. Second calc 5. Move over to the right-of-ways. Enter, enter, enter. And x equal 3. So those are your 2 solutions. Numbers 8 and 9 want you to list all the asymptotes, holes, the domain, and then graph the function. So I like to start by figuring out my horizontal asymptote, and then look for any holes, then my vertical asymptote, then my domain, and then I'll graph it. Before you can do that, you do have to factor it. And on this one, there's a number in front of x squared, so you got to take 7 times 2, find the factors of 14. 1 and 14, 2 and 7. Signs are different, and the largest is positive, so the small ones are negative, and they need to equal 5. Can't go to your sets of parentheses here. This is the long one. You're going to pull your 7x squared minus 2x plus 7x because of your factors, and then bring your minus 2. Cut it in half. You're going to pull an x out, and it leaves you 7x minus 2. Plus, there's nothing in common, so you put a 1 there, and it leaves you 7x minus 2. So the top is actually 7x minus 2 and x plus 1. The bottom, you can pull out a 2, and it leaves you x squared minus 9. And then you need to realize you have a difference of squares, so your 2 comes down, and it becomes x minus 3 and x plus 3. So the horizontal asymptote came from the original problem, which was 7x squared and 2x squared. Your exponents are the same, so that means there is a horizontal asymptote, so y equal. And you take your coefficients and you make a fraction. So y is equal to 7 over 2, because it was 7x squared over 2x squared. Wholes are anything that cancels. I do not have anything that cancels, so there's no whole. Vertical asymptotes, anything on the bottom that's going to cause a 0. So for the x minus 3, it's going to be x equal 3. It should not be a not equal, it should be equal. And then for the x plus 3, it's going to be x equal negative 3. So we've got x is equal to 3, and we've got x is equal to negative 3. You use your wholes and your vertical asymptotes to figure out your domain. So there are no holes, that doesn't affect it. Your vertical asymptote means that x is not equal to 3, and x is not equal to negative 3. So then I would go to y equal, and I would put the original problem in, and I would make sure that I use parentheses, and everything goes at y1. Okay, this is not a y1, y2 thing. Everything at y1. So open 7x squared plus 5x minus 2, close, divided by, open 2x squared minus 18. And so then all you really have to do is you're going to use your table and you're going to use your asymptotes. You have a horizontal asymptote at 7 over 2, which is 3.5. So you're going to go up 1, 2, 3 to about 3.5, and you're going to draw your dashed line. Okay, a little better than mine maybe. You have a vertical asymptote at x equal 3 and at negative 3. So 1, 2, 3. I have a vertical one. 1, 2, 3. Okay, so there's going to be 3 parts to this graph. Something here, and something here. So you use your table, and all it takes is 1 point to figure out what it's going to look like. But we don't want decimals, so I'm going to tell it to start at 0. And I'm going to look at my table, and I want something before the negative 3. So if I go up here to negative 4 or negative 5, it's 4.6. So negative 5, 1, 2, 3, 4.6. So it's above that. We've got curves forced. I can't go below that. I can't go to the right of that. That means it has to look like this. Then you need to pick a number between the 3. So let's just go with 0, and at 0 it's 0.1. Okay. If you wanted to pick some others, you could say that at negative 2, it's negative 1.6. So negative 2 is like down here. So that tells you that you're going to come up here, and you're going to curve, and you're going to come back down. And then we need something bigger than 3, so we can get that right part of the graph. So like at 5, it is 6.1. Something like that. So that tells you it's going to curve and do this. So that's what your graph looks like. The graph doesn't have to be perfect, but you got to get the basic idea across. Number 9, same thing. We got to have a horizontal asymptote. We've got to have a hole. We've got to have a vertical asymptote. We've got to have a domain. The exponent in the bottom is bigger, which means that y equal 0 is your horizontal asymptote. You've got to find the factors of 2. 1 and 2. Signs are the same. They're all positive. They equal 3. So x plus 1 and x plus 2 is what the bottom really is. So your x plus 1 will cancel. That causes a hole at x equal negative 1. The x plus 2 stays there. It causes a vertical asymptote at x equal negative 2. Your domain, x is not equal to negative 1. X is not equal to negative 2. That came from your hole and your vertical asymptote. So you have a horizontal asymptote at y equals 0. You have a horizontal asymptote, a vertical asymptote at x equal negative 1, and also at x equal negative 2. No, you do not have a vertical asymptote at x equal negative 1. Why not? Because it's a hole. And all a hole is an open circle in your line. So your vertical asymptote is actually at x equal negative 2. So we're going to go to y equal, and we're going to put this in. Over so we can see y equal, clear it out. Remember, you have to use parentheses. And on the top, we have x plus 1. Close divided by open. And on the bottom, we had x squared plus 3x plus 2. X squared plus 3x plus, not that many pluses though. Close parentheses. So go to your table. Find something before the negative 2. So like negative 3 maybe. And we have negative 1. So negative 3, negative 1 tells me it's down here. So it's got to do this. And keep in mind, we have a hole at -1. We're not there yet, but keep it in mind. We need to get something bigger than -2, so like let's go to 0, and it's 0.5. So 0.5, that tells me it's going to curve like this. But I have that hole at -1, so go to -1, go up to your line, and draw a circle for your hole. You got to include your hole or the graph is not correct. All right, the last part of the test just wants you to build functions. This is like when we had the Skittles. So draw your fraction. I have a vertical asymptote at x equals -2. That means I have x plus 2 on the bottom. I have a hole at x equals 6. That means I have to have an x minus 6 on the top and the bottom. And I've met all my requirements. Number 11 has a horizontal asymptote. Save that for last. We have a hole at x equals 3. That means x minus 3 on the top and on the bottom. Now, to have a horizontal asymptote, you either have, well, but it's specifically, it's at y equals 0. When you have it at y equals 0, that means the denominator is bigger. Well, I just have an x on the top and the bottom. I've got to throw another x down here so that I would have an x squared. Okay? It doesn't affect my hole at all, but it gives me the horizontal asymptote that was required. And then number 12, you have to have a vertical asymptote at 5, so x minus 5 belongs on the bottom. And at x equals 0, that means there's an x on the bottom. And you have to have a horizontal asymptote of y equals -2. If you have it at a number, that means that they are the same. X times x would give me an x squared, so I've got to have x squared on the top. And when I take my coefficients, it has to give me -2, so I need a -2 up there. All right, the only thing left was the bonus. I'm not doing the bonus because you don't get bonus when you do a retest. So make sure you turn in the original test and this test with the ones corrected that you missed. If you're not sure what you missed and you wanted to work the entire test for your retest, that's fine also. If you have any questions, come see me.